and today we are going to discuss about derivation of radius of an orbit. So, as Nielberg purpose is model about the energy of an orbit, and in which we discuss about the angular momentum, which was equals to nh upon 2 pi. On the other hand side, it was also equals to mvr, or simply in simple words, mvr is equals to nh upon 2 pi. So, without further ado, let's get started. Here, as we know that previously we derived the equation of mvr is equals to nh upon 2 pi is equals to nh upon 2 pi. Now mvr is equals to nh upon 2 pi from the first condition of Bohr, and mvr is equals to nh upon 2 pi. So accordingly, let us look at the diagram first. So previously we were known that there were two types of forces which were acting on the electron, which was a centripetal force, centrifugal force. Centripetal force were equal but in opposite direction. So what we are going to write here is that centrifugal force, as we know that here we are having an atom, and for suppose electron is moving from here. Electron is moving from here. Now, as electron is moving from here, that electron must possess velocity. Now, that velocity must be an initial velocity and a final velocity. Now, as it is having an initial and final velocity, if we are going to multiply both of these, that will become v square, and that v square would be considered as our first condition. Secondly, electron is having mass. It is having mass, although it is less than proton and neutron, but it is having mass. And the distance between electron and nucleus is known as the radius. It is known as radius. So radius is supposed to decrease the centrifugal force, due to which we are gonna write radius in upon, right? So as it is gonna decrease the centrifugal force, we are gonna write radius in upon, and ultimately this formula would be for centrifugal force. After which we are having centripetal force. For centripetal force, as we know, the Coulomb's law of attraction told that F is equals to k q1 q2 upon r square. Let us just type that F is equals to k q1 q2 upon r square. Now, as we know that this q1 q2 is in this condition would be what? Q1 q2 in this condition would be the electron and proton. Now first let us take the k aside. We are going to first discuss the q1 q2. Now q1, let us consider q1 is proton, and now proton is having its number of protons are represented by z. Number of protons are represented by z. But if you want to represent the charge of proton is represented by ze, which means that proton is having a positive charge. After which there is q2. Now q2 is what? Q2 is electron's charge. Electron's charge is represented by e only. So q ze into e upon r square is a condition here. After which we are, of course, k is also there. So k again, k ze square, because e will be multiplying with e, so e ze square upon r square. Accordingly, value of k is what? Value of k is 1 upon 4 pi epsilon naught. So when we're going to multiply that, so value of Coulomb's equation will be ze square upon 4 pi epsilon naught, 4 pi epsilon naught r square. That would be our final equation, which is also written here in the slide here. So right here we are having 1 upon 4 pi epsilon naught into ze square upon r square is equals to mv square upon r square. By equation 1 here, uh, as we know that equation 1 describes what? Equation 1 says that uh, mvr is equals to nh upon 2 pi. Now in order to calculate the value of uh, v only, if you want to calculate the v velocity, then velocity is equals to nh upon 2 pi mr. After calculation, that would be the condition. Afterwards, putting the value of velocity in equation 2 would be in such a manner that here 1 upon 4 pi epsilon naught ze square upon 4 square is equals to m upon r into n square h square 4 pi square m square r square. Why is that condition now? Because previously we were having the value of mv square upon r as v square. So here this is a square over here, as it is having a square, we should also implement a square over the whole condition which we solved in this condition. So after putting a square over this, the whole condition would be squared on the other side as well, due to which this would be the final answer: n square h square upon 4 pi square m square r square. So accordingly, um, z e square upon epsilon naught is equals to n square h square upon 4 pi m. As we are gonna multiply it and do some simplification, answer will be z e square upon epsilon naught is equals to n square h square upon 4 r pi m. Now, in order to calculate the value of R will go on the other hand side. Again, simple mathematical calculation will occur. R is equals to epsilon naught n square h square upon pi m z square. Now, uh, as we know that in these values there are some constant values as well as there are some variable values. Epsilon naught is constant, h square is constant, pi is constant, m is constant, mass is constant, and proton it is not constant. So here we are going to separate the constant values. Constant values will be separated, while n square and z square are variable values which will be separated. So the constant values would be considered as a single value which is known as a naught. That would be considered as the Bohr's constant, and Bohr's constant is having its value. As you can see, we can also calculate this constant value by multiplying the values. For example, first we are having the value of what? We are having a value of epsilon naught 8.85 into 10 to the power minus 12 into 6.62 into 10 to the power minus 34. Accordingly, we are going to add these values. We are going to multiply, and after algebraic simplification, we will have our answer of Bohr's constant as 0.529 into 10 s power minus 10 meter. But as we know that 10 s power minus 10 meter is equals to angstrom, which is a unit of radius of uh, an orbit, which is a unit of radius of an orbit. So here the value of r, the value of the constant will ultimately become 0.528 a, sorry, it's not a, it's m, a naught or armstrong. So it will become 0.529 armstrong. So after putting the value inside equation, back inside the equation, it will become r is equal to n square upon z is equal into 0.528 a naught. So this is all about this video. I'm hopeful that this condition taught you something new. And here, if the number of protons are increased, radius is decreased, as it is inverse relation. And if the number of orbit is, if the number of orbits and represents number of orbits, if it is increased one time, if it is increased two times, sorry, if it is increased two times, then the radius will increase four times. If it is increased five times, the radius will increase 25 times. As a simple physical expressions. And so this is these are some points which I wanted to discuss in this video. After which we are having condition that if we are having more space, as we discussed about k, which is or and epsilon naught, which is a value of permeability of free space. If we are having more space, then there is less amount of permeability. If there is more space, if you are having more space, or if you are having uh, more space, then there would be less permeability. There will be less permeability. I'm just representing it by p. So if space is more, permeability is less. If space is less, permeability is more. Both are inversely proportional. Hopefully I'm hopeful that you enjoyed the video, and we are going to move together into another exciting video.